This conference will now be recorded.
Hi all, so welcome to performance testing with JMeter Core to advanced level, and today will be day 5. Okay, so as a recap, in day 4 we continued with HTTP protocol, right? We have understood about like request response headers, then different types of HTTP requests, right? Basically these 4 which are important. Then we have understood about transactions, right, in detail. Then cache, cookies, and user session. Okay. And then we discussed the PTLC again. PTLC, we have understood the PTLC. Now today, so if I go back to that PTLC, yeah. So that is PTLC, right? Uh, generally we'll start from phase 3. So in phase 3, after identification and documentation of business scenario and the related transaction, we have to record, right? We have to record the re request and response for each transaction, right? For a particular business scenario on an application, right? And then we do the scripting and then replay and stabilization, and then phase 4 that is test execution. So this is what we will do in JMeter, right? So before we do, we learn like how these all things are done. What we will do is we will see some other concepts. Okay, so today we'll talk about some other concepts related to some server and the application type, right? Then from day 6 we'll enter into JMeter, right? Okay, so like so before starting the recording, another thing like day 6, 7, 7 and 8, right? 8 and 9. We'll look into some overview, right? Something related to JMeter, the introduction part, and then we do the like how proper scripting will be done, right? How the scenario, the scenario identification, documentation, and how the recording will be done. So that will start from day 9. Yeah, day 9, basically day 9, day 10, right? So let us talk about some other thing today. So today we'll talk about client side and server side performance testing. Fine. Uh, then we'll talk about the application architecture. So server side and client side or UI performance testing. Okay. So see, generally we do the this is important thing to understand. Okay. Please remember uh, what we are going to discuss. So generally when we do the performance testing, we do the performance testing of server side only. Now, what is the server side, right? So see, suppose I will open this uh, Mozilla Firefox and I'll open the F12 tab. Then let us say I'll open any website. Let us say I'll open the Amazon.com only, right? .in www.amazon.in. Fine. So when I'm sending this request, right? So response comes, correct? And you know how the response comes. The response comes in code format. Okay. You can check over here. You can check over here. Let us say this is the request. You can go to response and you can enable this raw, right? So this is how it looks. Or on the website also you can check like if you right click somewhere and you see this view page source. So if you click on that, the code format will be shown, right? So response always comes in code format. Now understand. So let me show this in Google Chrome. Then Google Chrome also same thing, right? Let me open F12. I'll enable disable cache and I'll open Flipkart. The Flipkart got loaded. Okay. So let me just delete this. Or here also delete option and all the same things are there, right? Like how it looks in Mozilla Firefox. So the network tab is same in every browser. Okay, just a second. So response come and response comes in code format. You can right click somewhere and you can click on view page source, right? This is the code. This happens for every website, even for Google also, right? Generally the Google that we open, right? This is Google, right? So if I right click and click on view page source, right? So see, this is the code. This is so complex code. This is the code and it's very big, right? That's it, this much big code, complex code. This is code for this page, this very simple page that we see. Okay. So the response comes in code format and the response is rendered and processed by the browser, right? That is what we have understood. Now see, so here suppose this is the Flipkart, so you can click here and this is the request, right? You can click on response if you want to see the response, and here this is what the code format. So either you can see here or you can right click and you can click on this view page source, right? That doesn't matter, we have to just understand that is what. Now see, when here three things are there. Okay, understand, three things are there. One is when I send this request, when I clicked on, I open Flipkart, so a request went and the response comes. Okay, now that response is coming to the browser in code format. So let us say this is the point where the response come, request went and the response come in code format, right? So whatever the time is taken for this process, that is known as response time. Normally that is called as what? Response time. Okay, now after that there are two things that also happens. So I'll talk about that two things later on. So this response time, so you are sending the request, it is going to the application to the Flipkart, and the from Flipkart the response is coming in the code format. So the time that it is taken, that is called response time, and generally that is known as server response time. Normally it is called response time, or you can say server response time. Fine. And that is and generally in performance testing we check this part only, that hey, I'm sending the request and I'll be receiving the response, how much time it is taking, and response generally that will be in code format, how much time it is taking. Okay, for one user or for 1000 users or for 2000 users, like that, or 20,000 users, like that, how much time it is taking. Okay, so that is what the server side performance testing. Okay, server side performance testing, you got the idea. Generally we do 90% of time we do this server side performance testing. Now once this code comes to the browser, right, once this code is coming to the browser, then what happens, rendering of that code happens, right? Now in the process of rendering there are two things that happens. One is retrieving of this all embedded resources that we see. So suppose the request went to the server and the response come from the server side in code format, so some time it took, right? That is the response time. So I'll give the time name as t1, right? T1, or assume like it took 2 seconds, fine, 2 seconds. After that, once this code comes to the browser, then browser renders that code, right? Process that code, and while processing it downloads these embedded resources, it loads some contents. Okay, it loads some content and all the thing. So there is downloading of embedded resources, so that is some extra time it takes. So assume that t2, Okay, that is T2 extra time, that is I'm saying. Let us say it took 1 second. Once all these things are downloaded, all these embedded resources are retrieved or downloaded, then what will happen, then this full website or full page will be loaded. Okay, it will be processed, you can say. So that, again, that will be another time. So let us say, let us call T3. Let us say it also took 1 second, right, for an. So this whole time that is taken by the thing, right, the 2 second this one, then 1 second for retrieving and 1 second for the whole processing. So total how much it is? 2 plus 1 plus 1, right, is equal to 4 second, right? 4 second. So this is called end-to-end response time. This will be called as what? End-to-end response time. End-to-end response time. Okay. Here, here what will be there? This server response time, that which we call, generally we call it as a simple response time only, plus the extra time taken by the browser to retrieve the embedded resources and then process the code, right, to load the content. Okay, so this extra time generally we do not measure in performance testing, like straightforward. Normally we do not measure, like that is not the scope. Even, yeah, we measure, right? I'll come to that. But you are getting the point, right? Just measuring the time till here, till the response is coming in code format, measuring the time till the response is coming in code format for one user or 1000 user or 20,000, that is called server side performance testing, and generally we do that only. Okay, this extra thing, that is, that extra time that is taken by browser over here, since this is browser dependent, okay, it is user machine dependent. Okay, because suppose your laptop is very slow, you have only 2 GB of RAM, right? So obviously all process will remain will run slow, right? Or you are running a very old you are having a very old CPU, so that CPU will process anything slow. So since these things are machine dependent means it's user dependent, these times are user dependent. So that's why generally these things are not considered, means it's not come under normal consideration or normal performance testing, right? Because someone will be having very high CPU, someone very good CPU, someone will have old laptop, so their things will be slow. So it doesn't matter that a website is slow, right? So that's why these things are user specific, right? Machine dependent, so generally we do not consider. But sometimes we have to test this also, how much it is taking. So this part, this thing, the retrieving of embedded resources and then complete rendering of the page, this is called client side. What it will be called? Client side performance testing. Getting the idea? Or UI performance testing. Many times you will see people calling it as UI. UI means user interface performance testing, right? So that is, there is difference. Okay, there is a difference, and there are three kinds of performance testing. Now you see here, when I downloaded, so here you see something will happen, like DOM content load took 3.24 second, then load took 4.26 second, then total this took this is in minute, I ignore this part. So ignore this one. So what happens is, see, when the response goes request goes, and when the response come, and when the response comes in code format, so some time is taken, right? The time is response time, and it's that suppose it's t1, right? T1, whatever time it is taking, so that time will be always less than equal to this time, DOM content, or yeah, less than equal to this much. Fine. Okay. And now you'll ask me, then what is this time, why it is higher? So this time is this browser is showing after complete loading of the page, so some difference is there, right? Plus this time is not actually the time for, see, this time, actually this time is not actual time for the response coming in code format. No, in tool we will get, in JMeter basically we will get how much time it is taken for the response to come to us in code format. But this time is not that. This time is once the code is coming and to the browser, and then DOM content load. Okay, DOM content load means there are frames are there. Okay, in a website, uh, multiple, like a web page is like house means different kind of thing are like, there are many layers. This will be like outer layer, then some layer here. Okay, uh, then some layer here. So these are called frames. Okay, these are all called DOM. So what happens is something get loaded first, something get loaded last. So outer frame, which get loaded first after receiving the time, that is what this is, right? And this is the time after full page load, right? So that's why difference is there. So actually you do not think that this is the time for response time in this is the time of the response time for the code, right, to achieve the browser. No, here we cannot get that. Here it is time after rendering, almost you can say rendering, and this is full rendering. Okay, one I'll show you how the DOM content looks. Let us say, suppose let me log into this website. Okay, so observe, see here you'll see these things get loaded little bit later on, right? I hope you have seen. Okay, let me show you just again one more time. When I log in, so you see something will be there which gets loaded first, and then something will be there which will be loaded in the last. So like that it happens in the browser. See, this here data will coming little late. You see, it's coming little late, but these were loaded little bit fast, right? Okay, so this is what this is happening on user end, and this happens because of the rendering and the code written, right? So this all comes under the uh, UI performance testing, okay, or client side, right? And that is what DOM. There, these DOMs are outer layer. These are outer layer which gets loaded first, then this which gets loaded last in last, right? Okay, so that is what the uh, server side and client side performance testing. Now you'll ask me the measurement, right? So measurement, see, generally in JMeter or in 90% of cases, as I said, generally we do the server side performance testing. We just bother about I'm sending the request, I'm receiving the response. Response should be coming, obviously response come in code format. In how much time that code is coming to me, right? For one user or for 20,000 user or whatever users. So that is what generally we bother about, and that will be the, you can say that is normal performance testing, or that is also called as server side performance testing, and this response time is called normal response time, right? Apart from that, the extra time that is taken by browser to download all the embedded resources, then to load the full page, these two extra time that is taken, that will be coming under client side performance testing. And addition of these two response time and this response time will be called as end-to-end response time, end-to-end response time, right? Now generally if you want to do client side performance testing, so JMeter is poor in that. Okay, understand. JMeter has limited capability in doing client side performance testing. But in server side performance testing, JMeter is fully capable. Okay, JMeter is fully capable in doing server side performance testing. But in client side, JMeter is lagging still if you want to do client side performance. Somewhat you can do by using JMeter and Selenium WebDriver integration. Selenium WebDriver integration, right? Using that we can measure this extra time. Okay, uh, but not that much in detail. So you'll ask me which tool can do this. So for now in market there is only one tool which can do this, is in LoadRunner, right? I have introduced you in the beginning only, right? We have seen what is LoadRunner. LoadRunner is a commercial tool, commercial performance testing tool, and it's highly featured performance testing tool. So in the LoadRunner there is a protocol called True Client Protocol, TC, right? True Client Protocol. Using that we can measure client side performance testing of any application more efficiently. Okay, In JMeter also we can do, but not that much efficiently. Fine. So that is what you must have seen in the PPT in the beginning. I have highlighted here like why to learn JMeter. In that, the UI or page load testing using JMeter and Selenium WebDriver integration. Right. So now I hope you have got the idea what is page load or what is UI testing and what is server side performance testing, right? And what are three different kinds of response time.
I have a question regarding this.
Hmm.
Yeah, so normally the client side response time, it should be higher than the server side response time.
Yes. Hmm.
Yeah, I mean
Yes.
it can be case. I mean whether there can be a scenario where the server side response time is higher than the client side. Can
No,
it
no,
happen?
no, no, never.
Okay, because I had observed a scenario where we had implemented the we were doing the client side, or we had captured the client side response time through Selenium integrated with JMeter, and it was having higher response time than the server side response time. Sorry, it was
That
it
is
was
correct.
having a lesser. No. Sorry. It was having a lesser response time, than the server side.
Okay, so you may be not be waiting for the correct element. This can happen. See, what happens is you have to wait. You have to give wait in Selenium when you are designing the script. Let us
Mm-hmm.
say when a page is getting loaded, so you have to check which is the element which gets loaded in the last, right? You have to give the wait time for that. You have to give the wait for that element. Then only we say uh, that page is fully loaded, right? So if you do not give the wait, what happens? The Selenium web driver will simply open the page and then it will close the page, even without the whole content getting loaded, right? So there you must have done some mistake. That's why it must be opening the page and closing the page without full content getting loaded, right? So yeah, the designing correct script is important. Here only, see, I just show you that these data are getting loaded later on, right? Then these are getting loaded, so you have to give wait that until unless these are getting loaded properly, then till then it should wait. The web driver should wait. If
Okay.
otherwise simply WebDriver has a capability, if you do not give the wait, it will simply open the page, it will simply close the page without
Okay. But
completely waiting for the page.
yeah.
Yeah.
Okay. But if we have inserted the code to click on any of the buttons, so that it was it was showing that once after opening the browser it was clicking that particular button and then it was proceeding ahead.
That's what I'm saying. It is, suppose this page came uh, and you next you are going to click on here. So it will click because uh, this page gets loaded and it clicks here. But what about this data which are not getting loaded, right? You have to wait and then click. Once complete thing is loaded, then you have to do whatever click you are going to do, right? You are
Okay.
getting the point what I'm saying.
Yeah. Okay. Okay.
Something
Okay. So
maybe as I said here, this page getting loaded first and your next step is clicking here, but
yeah.
you do not bother about waiting this time. So obviously it is gone, the time for this is gone. Simply Selenium WebDriver will open fastly this, and simply it will, once this is come, it will immediately click this and it will go. It will not bother about other thing, right? So that is what where you have to understand the DOM structure of the page, right? You have to know the iframes, right? It's not easy implementing Selenium WebDriver. You have to know the Selenium concept. You have to know the
Oh,
DOM. You have to get the idea which iframe is getting loaded last. You have to give wait for the element on that page which is getting loaded last. Then the full page is loaded, and then you can say you can bring the correct time, right? So if you want to learn about DOM, watch YouTube videos, right, on DOM structure. I'll recommend everyone to watch YouTube videos on DOM, right? DOM structure of a web page. Not big videos are there, that 15 minutes or 20 minutes videos are there made by many people. Okay, you should all watch.
Okay. Okay. Yeah. Thank you so much.
Yeah. Okay, so that is what uh, the client and server side performance testing, right? Now come to the next topics. So application and client server architecture, it's end time design and different layers, right? So see, in application there are basically three layers are there. Those layers are called as foundation layers. So like any house is built, so their foundations are there, right? Then different layers are there. So like that, application is kind of house only, so their layers are there. So what are those layers? Presentation layer or PL layer, business logic layer or BLL layer, and data manipulation layer or DML layer or data tier layer, right? What they do, I'll explain. And then there are types of application architecture. So these are layers, and then there are types. Okay, so types, actually there are four types: one tier, two tier, three tier, and multi-tier. Multi-tier architecture, people call it as an entire architecture, but it's wrong actually. Okay, this whole thing is application entire architecture only. Okay, right? And multi-tier is a fourth type of application architecture, which is an extension of three-tier architecture. So you'll get the idea what these are. Do not worry. So coming back to first tier architecture, right? So first tier architecture do not exist now. They used to exist long back when initially the computer world came in picture, right? You can say 1960 something. Okay, when application development and all the thing came in picture and internet was not at that time. So what happened at the time? One tier architecture means in one machine only everything will be there. One machine means here you can say laptop or a server, like that, bigger machine. So everything will be there. Everything means suppose you have developed one application, so every file related to that application will be kept in one machine only, right? So that was one tier architecture. Nowadays it's not there. It's there only in college, right, where you prepare the fourth semester project, right? Eighth semester project, right? There you develop mini project, right? So at that time you must have developed something to show you, to show to the HOD, right? And hope you have kept everything on your laptop only. So it's kind of one tier architecture, right? The DB and all the thing that you have set up. Then comes two-tier architecture. Fine. So two-tier architecture, there are two layers are there, two layers. And the two layer is divided into two parts: the database layer, which is one separate layer, and the client layer, right? We'll talk two-tier architectures are there nowadays. Okay, so we'll talk about that later on. Let us first go to three-tier, and then first let us understand about uh, the layers, right? Their layers. These are types, right? I'm talking about these are type one tier, two tier, and in that layers are there, right? So one tier means only will be having everything in one machine, and it is called one tier. Then in two tier there will be two layers, a DB layer separate and one client layer separate. So first let us understand three tier. Okay, and then we'll talk about these three layers, and then you'll get everything clear, right? The layers: PL, BLL, and DML layer. We'll talk about this considering the three-tier architecture, because nowadays this is what the three-tier architecture is going. So in three-tier architecture, see what happens: three layers are there. Okay, so first layer will be the PL layer, presentation layer. Second layer will be logic layer or business logic layer, BLL layer. And third layer will be DML layer, data manipulation layer. Okay, or database layer, you can say. The machine on which this layer is kept is called web servers, right? Web server. The machine on which these layers are kept, that is called app server or application servers. Okay, app server and application server. And the machine on which this layer is kept, that is called DB servers. DB servers. Fine, DB server. And these all are three different layers. They are interconnected. Right? You can say they are interconnected. Right? Interconnected. Three different layers. Now, first we'll talk about what this PL, BL, and DML layer are there. Right? So see, let me open one website, any website. Let us say I'll open ICSC. See, this is ICICI bank web page, right? And then this is Facebook web page, front page, I mean the first page, right? Now, this page is common to all. Anyone accessing the ICICI bank, these are the data which will be common to all. Same way, anyone accessing Facebook, this page will be common to all, right? So this common page is called a static page. Okay, static data or a static page, right? Static means constant, right? Fixed. And this is the layer actually. This is called presentation layer, or it is also called UI layer, presentation user interface layer, or presentation layer, PL layer, because this is the first layer to which the user interacts. Okay, user interacts with. Fine, this first part, right? Okay, so this will be the presentation layer, or you can say UI layer, user interface layer. Okay, now behind that there will be one more layer which is called BLL layer, business logic layer, which we generally do not see, but that is there on the server side. People will see this. This is also on server side only. Server means to the Facebook, towards the Facebook only, right? Toward the ICSC only. But this is the layer which we directly interacts with. This layer we do not interact with, because this layer is after this layer, right? Now what will be there inside that? So the code, okay, the code to do the business logic, the code that works for business logic, that code are written here. This is very main layer, okay, very main layer, because this is a simple layer, this is very main layer, right? So with example I'll show you. Suppose this page is common to all of you. Now you will put your email ID, your password, I'll put my email ID, my password, and we'll both log in. So you will get your posts, right? You will get your friend list, friends status or messages or photos. I'll get my friend status and photo and all the thing. So this coding, right, that to simply understand, to show what to whom. Okay, to show what to whom, that is done by this layer. Same way, suppose you are logging into ICSC, right? Then you logged in, or here also when you are entering the password, your verification of the password, your verification of email ID, whether it is correct or not, right? If it is correct only, then only you will be logging inside, right? Otherwise it will throw error also. So this processing, right, this, once you enter username and password, then it will come to this layer, and from this layer it will go here in the DB. Already your email and password will be there, it will be matched. If it is correct, then the output from here will be going with this layer to this layer, through this layer, and it will be shown to you. Getting the point, right? So that code to do the business functionality, even on let us say you are logging here, then suppose you log with your credential, I'll be logging with my credential. So you will be getting your own balance and other thing, right? I'll be getting my balance and other thing. So this all thing will be shown by some logic, right? So that layer, this layer does that. Okay, and in the last, this is the layer, last layer, that is DB layer. Obviously we know everything is data, and the data is kept where? In the DB one. Every data, like your friend's message, your account balance, your beneficiary that you have added in your banking portal, right? Your friend's message, your friend's picture, your messages, right? Your transaction history, all thing is where? It is in DB layer. And what things to fetch and to show to the user, that will be done by this layer, right? You are getting the point now. So these are the three layers that are generally there in any web, any application, right? Three layers. And as I said, this layer, when on the machine where it is kept, that is web server. On machine where this layer is kept, that is app server or application server. And on the machine where this layer is kept, that is called a DB server. Okay. Now this PL layer is the technology used to develop the PL layer is generally HTML language, CSS, JavaScript. Nowadays Angular JS is also there. Angular. Okay, Angular. Uh, right, Angular are there. So using this, the front end, this layer is made, and this layer is also called as front end, right? And you must have heard of front end developers, right? The front end developers. So those developers develop this layer only. Okay. Then this layer is generally coded, or it's made using some good language you must have heard, like Java, PHP, Python, Rails, .NET. And this layer is called backend. Okay, backend. And you must have heard of backend developers, right? So they develop this layer. And then this is a separate layer only. It's a SQL layer where a structured query language are this is done. There are many DB using which we are doing that, like SQL is there, MySQL, SQL Server, Oracle, PostgreSQL, many kind of SQL technologies are there. And obviously these are done, and these are called SQL developers, you must have heard of, or DB admins or DB developers, right? Right, this is what. Okay. And these all are interconnect, they are all kept on different machine and they are interconnected, and this becomes a whole full-fledged application infrastructure, right? Infrastructure. Now the modern day, that is what entire architecture, that what I said, the third layer, fourth layer, which is an extension of three-tier architecture. It's called multi-tier architecture. So in that what happens, multiple layers will be there. Sorry, layer will be three only, multiple servers will be there. Like you see, multiple web servers, multiple app servers, multiple DB servers, and interconnected. uh, in that many mechanisms are there, but understand here in simple way. So why multiple, right? See, there is one web server. On web server, what will be there? PL layer is kept, right? One app server, where what is kept? The business logic layer, BLL, is kept, right? And there is one DB server where DML layer is there, right? DML code is kept, and they are interrelated. Now in this world, everyone has a capacity, everything has a capacity, right? So suppose this web server has a capacity to handle only 5,000 requests per hour. This machine, the configuration of this machine and all these things, they can only handle 5,000 requests in 1 hour. In 1 hour they can handle 5,000 requests. Request means, right, 5,000 people are doing something, so 5,000 requests will be made. They can handle that, right, per hour, or let us say, I'll make it sort of per minute, right? Let me do like that. 1,000 requests per minute. In 1 minute, they can handle 1,000 requests only per 1 minute, right? Now, my application is big, and on my application daily, suppose 1 lakh people are coming, 1 lakh per minute people are coming. Then can this handle? No, right? It has only capacity of handling 1,000 requests, and my application is very famous, and 1 lakh request is coming per minute. This all can they handle? No. So that's why multiple web server will be there, multiple app server will be there, multiple DML server will be there. So that what will happen? That, and here you see, and then it's a very simple diagram. The actually diagram are very complicated, right? So here load balancer is there. You see, load balancer does what? Suppose whoever is busy, or whoever of this web server is free, right? So extra request, suppose 5,000 requests coming, and and then after that again some 2,000 requests coming. So the transferring of the request, whoever is free, transferring to some request to there, some request to this machines, like, so these are done by load balancer, right? Apart from that, security layers are also there. Antivirus layers are there, proxy layers are there, firewalls are there on application to save the application from hackers, right? Okay, so this all makes the application architecture, and this is called a multi-tier architecture. MultiTar Architecture. Okay, and that is all about the 3 layers and 3 different servers. Now coming to 2 kinds of application. So we'll go back again to the layers, do not worry. So coming to the thin client and thick, there are 2 kinds of application. One is called thin client application and one is called thick client application. So see, all web or browser based application, right? All those application which we access through a browser, those are called web application, right? So uh, and all those are called thin client application. So thin client application has 3-tier architecture, or you can say multi-tier architecture. In that, the PL layer, right, which is the first layer, is generally client facing or user facing, but it's not installed. Okay, the client user is user facing, it's towards the user, but we do not have access to that. It's not installed on the user machine, right? User is accessing that using a third party interface called browser. Fine. And the rest of the layers, the BL layer and DML layer, are on the backend. Obviously they are on the server side only, right? Generally these are centralized. Okay, centralized. Now another type of application is called thick client or fat client application. So examples of these are mobile application, mobile apps, desktop apps. So desktop apps are like a train ticket booking, color cab, bank employer, restaurants order accepting app, right? Now this thick client application or fat client application has 2-tier architecture. Right? That is what 2-tier, right? I hope you see. If you remember, I have just shown you a 2-tier architecture diagram. 2-tier, the client tier, and then database tier, right? 2-tier. So the client tier, uh, that is layer 1. You can say it's combination of BL and PL layer. That is treated as one layer. It's a client tier. It is on client side, and it is actually installed on the client side. Okay. There is no involvement of any third party interface to access this application. No involvement. Here involvement is there, right? We are using browser, but here the application will be installed on the system. I'll give example, do not worry. And the DML layer, the database layer, will be on the server side, centralized, right? So now we will see the difference between 2-tier and 3-tier. So see, all the web applications are having 3-tier architecture, and they are called thin client application. And the example I've just shown you, right? I've just explained that there will be a PL layer, which we will be accessing through a browser, right? And then there will be a BLL layer, and then there will be a DML layer or database layer, right? And we have to access this through a browser, a third-party interface, right? A third-party tool, a browser we access. But a thick client application, they have 2-tier architecture. So example of thick client application are mobile apps. So you must know, right? Any mobile app, let us say the ICIC. I'll take the example of two example. I'll give. Let us say ICIC and IRCTC. So IRCTC has an online banking portal, right? A website, and ICIC is also online banking website. So the online version that you see, the website that you see, it follows the thin client application, thin client or 3-layer architecture thing. It's a thin client application. Okay, and same ICIC has a mobile version as well, right? We install ICIC mobile app or any bank mobile app in our device. So we are installing that APK file from downloading from Google Play Store and installing in our mobile, right? Same goes for IRCTC or any bank, right? And there we are not using any third-party interface. Are you using any third-party interface? No, you are installing the complete application on your device and you are authenticating, right? Once your authentication is done, then you are just you have to just create a simple pin and you are always there. You can always open ICIC mobile app, just enter the pin and you are there. But here it's not like that, right? You have to open the browser first, then you have to open the portal, then you have to log in, then you have to go inside that. So difference is there, right? So here the first layer, first two layer, which is generally a combination of, you can say, client layer, which is P layer and B layer. It is there, it is installed on the client machine in your mobile, right? But the database layer is always centralized, even in this layer, because database is always a common thing. So we cannot keep database on any user machine, no, right? Database should be centralized. It is kept in the ICIC data center only, or any database of even IRCTC or any, it is kept as a centralized location. Because if you are doing some changes, suppose from your account you are sending some money, right, through web application, so it should if reflect at the end of day in the database only. And from mobile also, if you are doing the same thing, so it should reflect in your database, right? So if database is common, then only when these layers are retrieving the value from the DB, they can show you the correct amount, right? Okay, so database is always centralized. You're getting the point. So this is the example between 2-tier and 3-tier. There are multiple examples of 2-tier I can give, like one is the mobile app, right? Any mobile app. Same way, desktop apps. Many people call desktop apps. Okay, what are desktop apps? Okay, desktop apps are not the calculator. No. Okay, in our laptop calculator are there? No, it's not desktop app. Here desktop apps means different thing. Even if you see Microsoft Word, it's a desktop. No, no, it's not like that. See, desktop apps means mm, a, a part of the application will be installed in your laptop or in your PC, like how in mobile thing we are installing the APK in our mobile, right? So same way. So example, you may not be correlating, but I'll tell you. Let us say if you go to the any bank employee desk, okay, you visit any ICIC or any bank employee desk and you try to see their screen. Any employee when he is working, you try to see his screen. He will not be using the, suppose you are visiting ICIC uh, bank. So we have ICIC online banking system I've just shown you. But if you try to see that employee screen, he will not be using that ICIC online banking system. No. Okay, this is for us. They have a separate portal, their own portal. Okay, which is just installed. Some part is installed in their laptop, and that's why in this pandemic also they cannot carry their laptop to home because of security reasons. They all the banking employee were working so hard even in the pandemic, right? They have to go to their office. Okay, right? So some part is kept in installed in their system, right? Same way, uh, railway ticket. If you remember the old days when we visit the railway counter, so if you must have seen, there will be a dark screen, and that is still called as DOS operating system, using which the clerk is booking the ticket for us. If you got any chance, try to visit, right? And you see, it's not, he is not using the IRCTC. No, he has his own portal in his in behind his screen, right? It will be dark like a screen. Okay, so that setup, or you can, let us say, go to ATM, right? ATM only, you see the there is a setup which is there in ATM. Okay, same way. So in ATM machine, setup is kept. You are not using browser to operate the ATM. You have to, setup is kept in that machine, right? ATM is what? It's also a CPU. It's also a server, right? You are just going and touching the thing because it's a machine only. It's a screen only, right? A touch screen. But inside that CPU is there, another thing are there. Some things are kept. So those are called desktop apps. Even uh, so further, like Zomato, right? So Zomato or Swiggy. So the just Zomato, Swiggy has three thing. Okay, again three. One is online portal, then one is mobile also, and one is, right? So using this mobile and online portal is for us, for a user who can use them and book the order. But the order is going to some restaurant people, right? So if you get any chance, even nowadays a small restaurant is accepting order of Zomato, Swiggy, just go there and try to see their screen. Okay, you will see, I have seen, right? It's there, it's many where there will be a screen where you can ask him, he will be accepting the order. When any people is booking the order, there in his part the order will pop up. Okay, So that screen will be totally different to what we are using, right? So that is a setup given to them, that is a totally separate system. So they, in that, what happens, some part is installed at their end, and DB is obviously centralized, right? DB is kept at a separate location, centralized DB is layer is common. So those kind of application are called desktop application, and they follow two-tier architecture. Fine. So a small example here, like you see here, this is one multiple layer. So this is business layer, sorry, this is PL layer, business layer, and data layer. Here firewalls are there, right? Web servers are there. So the external users are accessing through browser, through this firewall, the web server. The request is going from here, then coming to the app server, then DB, right? And the response is going back. Then the internal users, they are here. So for internal user, generally it's only one layer, combination of one layer only. Internal user means what? Through mobile, who are using, or the desktop apps of that company, uh, right? Or ATM, like just now I've shown, right? Talked about the ATM two-tier architecture. So they have only one layer. PL layer and BL layer will not be separate. It will be common, and then they will be just interacting with the DB, one layer and the DB for them, right? So one example of so see, any application when it is developed, it has a blueprint, okay, how, which technology is being used to develop it, right? So you should know that. That is called technology stacks. It can be asked in any interview, like, can you explain me the architecture of your application? So when he asks, he wants to ask the application of architecture of the application, right? So it means what? You have to tell them that using which technology your front end was built. If you are doing the performance testing of a thin client application, right, means a web application, so using which technology your front end was built, using which technology your back end was built, using which technology your DB layer was built, right? Plus on which kind of server they were kept, right? On which kind of environment they were kept. Environment means what? See, everything is kept on different servers, right? Everything is kept on a different server. Server means what? In the beginning I told you, server means what? It's a machine. The machine consists of what? CPU plus memory, right? Memory means RAM memory. Then inside that operating system will be there. In operating system nowadays, all thing is cloud, but in that also Windows is there, or Linux is there. Generally many people use Linux. Then inside that, server software will be there. One server software which manages the request. Okay, there are different types of server softwares, like Tomcat servers are there, WebLogic, WebWhisper, this kind of server softwares are there. And in that, the application is kept. The uh, uh, the front end, or the this back end, the BL layer or DML layer, inside that, that is kept. So you have to explain all these things, right? How many web servers were there in your project? How many app servers were there? How many DB servers were there, right? What was the technology used uh, to build your uh, uh, to build your front end? What were technology to used to build your back end? What were the DB technology used, right? What was the operating system was used? What were the server software is there inside that, that was used? These things we have to explain. Generally it's good if you have the idea, right? So that's what one example, like, I will give you in real time. So this is an example from web application. So you see, the front end, this whole application is there on Microsoft Azure cloud, because everything is on cloud nowadays. Azure cloud. The OS is Windows Server, right? OS is Windows Server. The UI layer is made of HTML. HTML is always there, and AngularJS, and .NET PVC. It's hosted on server software called IIS 7.0. Then app layer was also built on .NET. It was a .NET application, so .NET, right? And this was also on Windows Server only. And in last the DB was on Microsoft SQL. Right, like that blueprints will be there of any. Same way this one. This is on Amazon AWS. Okay, this is hosted on Amazon AWS. So the front end, the web server, right? You can see it. Two web servers are there. They are on the Windows EC2. Windows EC2 means the operating system was Windows, right? And in between load balancer is there. As I said, the from here the load is coming. Am I not audible? Hello.
Yes, sir, you're audible.
Okay, okay, yeah. I'm audible. Please check your connections. It's almost finished only. Those who are missing, they can watch the videos. Yeah. So right. So and here load balancer is there. So from here the user will be accessing, the load will be coming here. It will be elastic load balancer is there. It's a technology in Amazon. The load will be balanced to the web server. So from that again the load will be coming to the app server, right? App server. You see, app server was there on Linux operating system, right? And here also load balance is there to balance the load. And then in last the DB is there. So in DB there are two types of DB: primary DB and secondary DB. So why these setups are there? Because for backup, right? Backup we have features. So MySQL was the MS SQL. Actually, it's not it's MySQL, MS SQL. MS SQL means Microsoft, yeah. Microsoft SQL Server was the primary, and then MongoDB, that was secondary. Okay, secondary DB. In that also primary secondary concept was there. Fine. Ignore that. This is a simple uh, illustration. I'm saying that how things looks. And then same for the same. If you see here, mobile is there. So a mobile user, uh, for him. You see there will be only one layer, right? Because this some part of the application will be installed on his app. So for him, you see the request is directly coming to this part. For him, uh, this part is ignored. The request is directly coming from here to this part, and from here the load is the distributed, and the
Vallabh,
information is fed and delivered here. Yeah. Many people are complaining not able to hear. Two people are complaining. Others can hear, right?
Yes.
Those who have joined from web portal, they cannot hear. Okay. So right. So right. You see. So for mobile person, see what is difference is any even let us say ICICI app or HDFC, whatever you banking app you have. So when you install that, uh, many things are there in your device, right? Only what is updated, the balance is updated, because that will be fetched from the DB
Vallabh, we are
central
not able to
location.
hear you.
Others can hear.
Hello, hello.
Yes, hello.
What is auto scaling here? What is the meaning of auto scaling?
Auto scaling is a cloud technology. Okay. Where is auto scaling? Oh, there a diagram. Huh? Yeah, that is
Yeah,
cloud technology. So that will be not a part of performance testing, but simply I'll explain. These are uh, nowadays the technology where suppose any resource, right? Suppose load is coming. The Flipkart example I told in beginning, you remember that? Hey, suppose 10 lakh people is coming, 10 lakh user load is coming, and your system you have made ready to handle 10 lakh users, but suddenly some extra load is also coming. So auto scaling feature helps in increasing or expanding the resource when extra load comes, right? So that is all cloud concepts. uh, this is not related to performance testing, right? This in the right, but yeah, that is what auto scaling is. Okay,
Okay.
so that is, yeah, so that is what you see. So for a mobile user, the for him only two layer is there. This is how he interacts with the application. And for a web user, this is three layers he has to follow, right? He has to come in the three layers, right? That is the difference of two tier, three tier applications. So till now we have learned all these things, like, right, this is what we have learned. If you see the user session, a complete user session, the user or business flow is there. In that, many transactions are there, right? Okay, in that transaction in between, the think times are there, right? When we do the action, the request is going, the request goes in HTTP HTML format, the main request. Apart from that, embedded resources are there, and this goes to the application, right? In the application, generally we interact with the PL layer. So in the PL layer, that is application. Then outside, the operating system will be there, and the outer hardware will be there, which will be the server, right? Server. Okay, right? And that is what we have to do. We have to do the performance testing. Means what? We have to simulate a user behavior, not user behavior. If we have to simulate a user doing a business scenario, right? Doing a business scenario and putting the load on the application for one user or for multiple users, and then check the response time and check the application behavior, that whether it can handle or not, or what error it is throwing. That is what we have to do, and that will be done using a tool, any performance testing tool, right? So that is all about the core concepts of performance testing. Fine. Then from tomorrow, from next day, not tomorrow, from next day, we will go and enter into JMeter, right? Okay. So that is all about core concepts of performance testing. Fine. So now from Monday, yeah, Monday we will enter into JMeter, right? So next session will be on Monday. We'll do a session on next Monday, next Tuesday, and next Wednesday, 3 day. And this will be open sessions. And after that session will be closed, you have to enroll, and then new session will be the after that new session means the next class after Wednesday will be in the next year. Next year means maybe from 3rd of January or 4th or 5th January. Okay, like that. So why we are keeping open session? So that people can decide, right, whether to join or not. Yeah. So thank you for attending. Have a good day.
Thank you.